All right, guys, final session. Find your chair or find a chair and sit down in it. So the last session is internet characterization through measurements. And guys, hey, we really do want to restart now. Sorry. Hey, this actually works. Internet characterization through measurements. We asked Ethan to do a keynote, and then we again have a bunch of lightning talks. This will also be a longer session again, so the number of lightning talks will be a bit higher than in the last session, which is why we try to keep on time. Go, Ethan.
Great, thanks. So we talked earlier about important data sharing concerns such as privacy and metadata. I'm also going to talk about a hurdle to sharing, which is that researchers may not view the incentives as aligned for them to share their measurements or maintain their measurement systems over time. Rather than talking about particular characterizations using measurement, I'm just going to talk about this general idea that there's been so many great measurement projects out there that I would love to benefit from, but it's been hard because they're not necessarily available. I'm actually going to argue that there are substantial benefits even within the academic incentive system to providing these measurements, and I'm going to try to start a discussion about how we can maybe rebalance the trade-offs to strengthen the benefits and have measurement services that are operationally relevant. So what is internet measurement? An internet measurement conference paper might start with some vantage points, collecting some sort of data, generating a data set. You then might ask some questions using this data set, get some results, and then write a paper about it. So at this point, we have the fire and forget paper that Lars mentioned in his introduction, or Brian's that's interesting, motivation for research from his keynote. But we'd really like our work to have impact. And a traditional kind of academic measure of impact is if it inspires further research and further questions that either you pursue or that other people pursue based on it. Of course, ultimately, we'd like our research to impact internet operations. And as an example, I'm going to talk about a TCP measurement study that we conducted that ended up influencing some internet operations. I'm going to talk about that TCP work and what enabled it to have that influence. Then I'm going to mention the major challenges that we often face in academic research in order to have such influence. Since one of those challenges is the lack of data, I'm going to argue that more research could achieve impact if it provided its measurements and tools on an ongoing basis after the paper is published. And that will help others overcome the challenges. I'm going to give two examples from research that my students do. And then I'd like to finish with a discussion just of the trade-offs in providing measurement services to the community, hopefully as a bridge to more discussion about how we can encourage that contribution, kind of continuing the discussion we've already had today about sharing data. So the TCP project that I'm going to talk about shows how, given sort of idealized conditions, measurements can influence operations and maybe even standardization efforts. We worked with collaborators at Google to look at Google's TCP performance. So when you connect to a web service like Google, you'll connect to a front-end server that will terminate your TCP connection, and then it will relay your requests to a back-end server in a data center. And we collected TCP dumps containing billions of traces from real clients using Google. The summary of the result is that Google is very fast if there's no loss. So the graph up there buckets all of our client measurements based on the distance in RTT from the client to the front end. So the left bucket is kind of clients who are fairly near their front end, middle bucket, medium distance away, right bucket's far away. The y-axis is showing the TCP completion time, and the red bars are showing ideal TCP performance if you can deliver all of the content in one round trip. And within each bucket, it's the average performance. Blue bar shows Google's performance if there's no loss. And you can see when there's no loss, it's nearly ideal performance. Green bar shows the performance when there's any loss. About 6% of connections experience loss. And when there is loss, performance is 5 times slower on average. This is because of the delays caused by TCP loss detection and then loss recovery. So the measurements show that we really need to improve loss recovery. And there are other details in the paper, but what we did was adapt loss recovery to the specific loss pathologies that we saw in our measurements. Also, the client's connection has this two-stage aspect to it, and there's different conditions in the two parts of the stage. So we designed different mechanisms for those two settings between the client to front end versus front end to back end. I'm not going to go into the details here, but you can look at the papers if you're interested. So we deployed these two techniques in production at Google, and we achieved an average speed up of 23%. This is even though we were only affecting the very small fraction of connections that had loss in them. And the reason we were still able to achieve high average performance, even though most connections didn't have loss, is because the ones with loss were way out in the tail, really, really slow, and we sped them up a bunch. So some of our collaborators upstreamed one of the techniques into Linux. My student Toby won the Applied Networking Research Prize last year, and two of the techniques were submitted as IETF drafts, although they since expired. So, as Lars said this morning, writing a paper isn't enough to get it deployed. So I wanted to talk about what advantages did we have in that TCP study that let us kind of have this impact. The first was that we had access to great data. We could actually run TCP dumps on real production traffic from Google servers around the world. We also had a real problem to work on. Google knew that it had some slow connections and wanted to figure out how to speed them up. Finally, we had a good pathway to deployment for any changes we wanted to make because we could experiment in production at Google, and then also had collaborators who had experience upstreaming to Linux and also with IETF standardization. So why can this impact sometimes be hard to achieve? Well, often in my academic research, I don't have the ability to actually change code at Google servers around the world. And instead, I have kind of limited options available for evaluation. Can't necessarily always collect traffic from all of the vantage points of Google servers around the world. And instead, the data that you have access to ends up impacting the analysis that you do. And then we don't always have great visibility into the operational concerns to even know which problems to go after in the first place. So I'm going to zero. For operational practice and standardization, we want to be able to answer things like, what issues actually matter? How much do they matter? And what can we do about them? The answers that you get to those questions can be heavily shaped by the data that you have available. And measurement studies are often constrained to small data sets or short windows in time. This limited data that you have can both hamper the applicability of your results and result in subpar conclusions that maybe don't apply on a broader basis. Further, since many of the bigger data sets end up being private, it can be hard to verify results or to compare to and build off of earlier work. I'm going to give two examples. The exact questions and results on this slide aren't really important at all. The point is just that answering measurement questions on the internet with limited data and with fast internet evolution can be tricky. So one really simple question that we can ask is, how long are internet paths? And one answer you might get to that is, we did a study, 80% of the paths are at least 3 AS hops long. And this is if you look at paths from Planet Lab, which is an academic testbed and issue measurements to prefixes around the world. And then if you look at BGP route collectors like route views or Riz, you get a pretty similar number to that. On the other hand, many popular services that we use today are cloud-based. And if you instead look at paths from the cloud to eyeballs, you get a really different answer. So in this case, we did some measurements, and most of those paths are just one hop long, cloud connecting directly to the eyeball networks. So the characterization that you get from your measurements depends a lot on the specifics of the data set. Stale results end up also having an impact. So papers and submission deadlines are often checkpoints for gathering data in academic research. And you can end up missing evolution of the network if you only look at the papers. So just to give one example, if you would ask me 3 years ago during IMC 2012, how many locations Google had servers in around the world. Well, our measurements said 200 locations at that point. If you had submitted a paper to IMC 2013 answering this question, you would have seen 400 locations. And then if you had presented your paper at IMC in 2013, by that point, a few months later, it was suddenly 1,400 locations. So if you stop with just a snapshot of data, you'll get a different answer. So the question that I'd like to discuss today is, how can we still have impactful measurement studies despite all of these challenges that we face? My experience has been that there's at least that I want to talk about two great ways that you can have impact. One is to set up your measurements to run regularly rather than just conducting the measurements for a paper. Another is opening up your data and test beds for use by others. And collectively, I couldn't come up with a great term. I'm just going to call these sort of long-running open measurements or test beds measurement services. Some characterizations are limited because they go stale. Others because they lack the data that they need. So if you can contribute by making fresh data available, you can help others overcome these challenges and then increase the impact of the study. I'm going to expand on this for the rest of the talk using a couple examples from our research. So I'm basically going to argue that a project's impact, that you can add to a project's impact by first sharing data sets back with the community, which will then enable those data sets to be used for other research. And then continuing to refresh them over time. And second, by striving to make your test beds and tools available for long-term use. So if there's something that's useful for you, likely be useful for someone else. So the idea that contributing tools, test beds, data is a useful contribution, it's probably generally accepted, but I think that it's still worth talking about for a couple of reasons. First, I want to really emphasize the value. I've encountered many measurement studies, including some of my own, that ended up having limited impact because they went stale or they weren't available for other people to use. And then I also want to discuss how we can kind of encourage these sorts of studies, because I think they can end up contributing to other people having impactful research that ends up actually affecting how we operate on the internet. And so I'd love to discuss things that we can maybe do as a community. So I'm going to use two examples from my research, one on a project on mapping Google's infrastructure, and another on a BGP testbed that we operate. The first example is one in which we found value in regularly updating our measurements both before and after the paper. So I first want to just explain what we're measuring so you have the right context. So Google has data centers around the world, or CDNs have data centers around the world, and some clients will be underserved if they're not nearby. So a lot of companies deploy front-end servers, and then you can direct the client to the nearby front-end server. It'll relay the connection back to the data center. So we wanted to answer the following measurement questions. Which networks and which geographic locations have servers? Which clients use which servers? And then we wanted to be able to answer these questions globally so that our results weren't just limited to, say, the servers that are used by Planet Lab, Vantage Points, or something like this. I'll give a little bit of background just so you can understand it and quickly walk through this. So how does the client know which Google server to use? It's going to issue a DNS request through its local DNS resolver. The local resolver will forward that on to the authoritative resolver. The authoritative resolver will reply with the address of a particular server. Local resolver passes that back to the client, and then the client uses that server. So when the authoritative resolver made its decision about what reply to use, it had access to which resolver was making the request, but it didn't necessarily know which client. So it has to make a per resolver decision. So this works really well if all of the clients of the resolver are located near each other. But some resolvers have clients spread around the world, and in this case, there's no single good answer. So there's been a solution for this put forward as an IETF draft, the eDNS client subnet. And with that, the DNS resolver the local resolver will forward on a prefix of the client's address, and now the response can be made using the client's prefix. So my student Matt uses this eDNS client subnet prefix to completely enumerate front-end servers around the world. First, you can issue a request for one prefix, get back one server, issue another one, maybe you get another server, and so on. So we end up using eDNS to simulate having vantage points everywhere around the world, and that lets us get a complete client-to-server map for the entire IPv4 space. We also have some techniques for geolocation, validated that we can locate these servers well. I'm not going to go into them at all. We originally set out to demonstrate that our techniques worked and to compare different CDN infrastructure. And when we did this, we set up the measurements to run daily so that we could have fresh data once we actually got around to writing the paper. So our first data set was from about 3 years ago. And at that point, Google had about 200 locations around the world, and we were comparing them to other infrastructures. A week before the IMC submission deadline, we noticed that there had been like a doubling in the number of locations. So we scrapped our initial paper, rewrote it from scratch, and wrote a paper instead about this big expansion we'd seen. It seemed more interesting. We continued making the measurements while the paper was under review. And by the time we submitted the final version for the conference, it had gone from like a doubling to a 7-fold increase. And we again scrapped the paper and had to rewrite it because the results no longer held. So we got really lucky with our study, with our timing. We caught this shift in strategy and this huge expansion. And so I wish I could claim that you would see similar massive changes every time you run longitudinal studies. But what's the benefit of actually running your measurements over long time periods if you may not actually catch things like this? Well, first of all, it does give you the chance of catching these sort of changes. And without ongoing measurements, it's really hard to know when your measurements have gone stale. Another benefit is that it gives you an ability to join with other data sets easily. So this is actually why we originally started doing our measurements daily. We wanted to be able to incorporate new data sets as our technique evolved. This has also been useful since publication. For example, we collaborated with Nick Feimster and some of his students and other collaborators on a project looking at interconnectivity in Africa. And the African front ends hadn't existed when we published our paper. But because we had kept the measurements running, suddenly we saw new locations coming up there, and we're able to do this study of how interconnectivity was evolving in Africa. And it's not just useful for your own work. When you have up-to-date data available, it makes it easier for others to incorporate it. So hundreds of researchers have accessed this mapping data. And for example, people have used our data to identify which IP addresses belong to Google so that they can join it with passive traces. It wouldn't be really straightforward to identify which traffic in a passive trace was coming from which network if we didn't have data available on the day of that trace to make the mapping. On the flip side, I've had instances when I really wanted to use some technique that I'd seen maybe at IMC, but I couldn't because it wasn't publicly available. So I'm going to talk quickly about one more project, our BGP testbed peering. Route origin authorization has now been standardized. You can use ROAs to specify which network is valid for announcing a particular prefix. We're starting to see some adoption of that. There have been studies looking at how many ASs are registering prefixes and which prefixes. There have been studies of our routes that you observe, say, in route views data, honoring these authorizations. But this sort of BGP security is only effective if other ASs honor your authorizations. And so we'd really like to know what policies are ASs using in the wild. Are they even checking the ROAs? If they do, what do they do when they see an invalid one? So it's typically been hard for academic researchers to conduct this sort of experiment. We have two general approaches. One, we can use kind of measurements of routes as they exist using traceroute or looking glass servers. And this gives you an actual view into routing. But to do this study of route authorization policies, you would have to kind of sit around and wait until invalid routes were announced and then see what you observed. And it would be really hard to get good coverage. You also wouldn't have any precise control in order to exercise policies. The other common approach is to use simulation, but our knowledge of internet topology and policy is so limited that the simulation is going to be restricted by our ability to configure it properly. In this case, we're trying to answer a question about policies that no one's ever looked at before. So we want to run this on the internet. It's typically been hard for academic research to conduct these experiments because we lack control over actual resources. So what we've done is deployed a testbed AS, connected it to the real internet to let us run experiments like this in the wild. So we call it testbed peering. We have 9 universities as providers. This means that we actually have routers at these universities that establish BGP sessions with the university's routers. We can then deploy a software router or an emulated ISP and transparently connect it through peering to the upstream providers. We have a bunch of prefix spaces, including this /19, and we can allocate some of that to an experiment. It can then announce routes. This will result in ISPs around the world learning routes to it, and then when they send traffic, maybe it'll follow the paths like this back. And you can also select routes out to the internet and then send traffic. So, this example wasn't very interesting, but we can actually use this setup to investigate the questions of ROA adoption that I raised before. And I'm just going to give a simplified version of how that might work. So in this case, we can do something like, let's say, first announce valid routes through 2 different providers, and then ASs will select the routes that they want to use. We can then change one of the announcements to make it invalid. This will propagate through the internet. Probably most of the ASs aren't going to be checking whether it's invalid, so they're going to just keep using it anyway. But maybe Global Crossing in this case, when it gets it, will actually check, reject the invalid route, and choose to route a different way instead. And because we've observed this change, we know that it's in response to this, and we've learned something about their ROA policies. Now, of course, no actual networks have 9 universities as providers. We're expanding into internet exchange points. We're in a couple right now. We're working with Randy to get into some more. So we originally started building and using this testbed ourselves for one particular study. It wasn't actually this ROA one, but it gives you the flavor. But it seemed more broadly useful, so we've worked on expanding it and actually opening it up for others to use. It's been used for 8 papers in the last couple of years, topics including routing availability, performance, security, routing policies. We'd love for other people to use it as well. So I highlighted earlier benefits of having the CDN mapping data that we've done open and public. Now I'm going to point out other benefits using this peering example. Any project that you start requires some startup costs. And when you reuse some of the infrastructure, you can actually amortize those costs across multiple projects. So it's actually quite a bit of overhead to set up this AS. We have routers on 3 continents. We have a lot of peerings, but now it's easy for us to run new experiments. And it lets us run things that maybe we've thought about for years, but didn't have a way to run. Plus, it's inspired new projects. And of course, because it's available for other people to use, that's one measure of the project having impact. And a really interesting thing that's happened is that other people have seen different ways to use it than I had originally envisioned. And often they end up involving you in their work. So in this case, I had never worked in routing security or software-defined networking before, but people came to us wanting to use the testbed for these sorts of studies and ended up involving me in them. So it's been a way for me to branch into new areas. So I've painted kind of a rosy picture so far, just showing benefits. Of course, there are some trade-offs if you're going to maintain your measurements over long time periods, especially after you've published the paper, and if you're going to open up your measurements and test beds for use by others. So, known issue within academia is that it can be kind of hard to fund these ongoing efforts. Also, students graduate and things decay. It requires extra work to do this, and even more work to open it up for others. And this is kind of an opportunity cost. Like, should I move on to new unrelated projects versus maintaining the same one? Another concern that some people have is that when you lose your kind of own advantages if you're opening up your stuff for use by others. I actually tend to think that that's not usually a big concern. Hopefully, research isn't a zero-sum game. We're all kind of trying to move forward in our knowledge, move forward in how we operate the network. The other thing is, like I mentioned with this routing security, other people end up having different ideas than you have anyway. And if they're going to do the same thing that you were doing anyway, it's a good chance for you to move on to something new. There was a concern raised earlier which is that when data becomes available, people end up using it because it's the data that's available rather than because it's the right data to use for the question that they're trying to answer. And then there are serious privacy concerns with sharing certain types of data. That's been discussed already today. I'm not going to discuss it at all, but John Heidemann had a good keynote talk at PAM last year that looked at that. What I want to discuss instead is in the last part of the talk, how can we kind of encourage long ongoing measurements and open test beds that will help us do useful research. What can we kind of do given these trade-offs to tip the balance towards the strengths? I'm going to share some ideas that I have, but I'm relatively new to IMC compared to some people here. I'm completely new to IETF. This will be my first one. So I'm not going to pretend to have any definitive answers. I'd really much rather hear from others what has been tried before, what's been proposed, what you think we should do going forward. I'm going to talk a little bit about what IMC does and some ideas I have on what it could do, and then touch a little bit on IETF drafts and what role they might play. So right now, IMC does ask for papers that have some of this flavor. The call for papers specifies what topics are in scope for the conference, and it does mention advances in facilitating data sharing. It mentions reappraisal of previous findings, so I think these are great steps. There's also an IMC community session that happened a couple of evenings ago where people can kind of advertise data and services they have available to the community, and a number of people here actually got up and advertised what they had for use. There is also an IMC award given out each year for the new paper that made available a novel data set to the community. So there's some recognition of the value in that. Somewhat related to that, NSDI and SIGCOMM are my other two main conferences, and they've added operational systems and experience tracks. And these are to get papers that don't necessarily have novel research contributions, but give insight into either experiences with long-running systems or with operational experience running on the internet. So while IMC kind of encourages papers along those lines of the operational and experience tracks, I think they sometimes meet resistance. So it's maybe worth considering a similar track. Randy mentioned before needing a way to search for data. And I think that since IMC and other similar conferences ask papers to check a box if they're contributing new data sets, it's worth considering curating a guide to those data sets and possibly even hosting data sets so that they can live on after the students graduate. In conference reviews at measurement conferences, there generally isn't any acknowledgement of this type of contribution explicitly, whereas some journals actually ask, what's the likelihood of this work to influence practice and research? And I think considering having some language on that in the reviews, even though it's not the highest priority of these papers, might encourage people to think along these lines. I threw up an idea here from Harsha at University of Michigan. So he wants to have an exit poll for conference attendees. What data from the conference do you most want? And it will be kind of a signal to people that they've done something that's useful. We'd have to work out the details on that, considering, probably if we just had an open vote, everyone would vote for, whatever was the most privileged data that existed. But I think it's an idea worth considering. And I think it's also worth kind of acknowledging Harsha here because he's maintained Planet Lab trace routes to kind of hundreds of thousands of prefixes around the internet daily since 2006, even though he doesn't really work in internet measurement very much these days. And that idea of maintaining these things over a long time period brings me to my last idea that I have here. So we have this award for the best data set at the conference, but it's given to papers that have just appeared. I think it would be interesting to consider giving some sort of test of time. When a paper first appears, it's too soon to judge its impact. Other fields have test of time awards for papers that have had large influence. I think it's worth considering test of time for people who have maintained data sets, maintained test beds and tools for other people to use that have ended up being influential and useful. I have a couple things that I've been using for years listed up there. So I'd love to hear in the discussion period ideas that other people have, I'm sure better than mine. So I'm a first timer to IETF, so I really don't want to hazard too many ideas on the role of But I do want to talk a little bit about the role that drafts and standards can have. So RAIM is about bringing together IMC and IETF communities. And I thought it was interesting when I got to the end of these slides to think about what role did IETF standardization have in the story that I've been trying to tell. So I want to talk about what role it had in the 3 projects that I mentioned. So a traditional view might be that we do measurements to understand the internet. These measurements might influence the standard, and then the standard influences operations. And that's maybe similar to the TCP project that I talked about. But you can also think of there being outputs from standards that can provide inputs into other projects. Brian talked before about the role of IETF's drafts and standards in measurements. Some have this direct goal of enabling measurements. He mentioned ping. Often we reappropriate techniques for measurements, like how traceroute hacks TTL. And so I think that as people who like to measure the internet, it's useful to look at new drafts for new potential hacks and measurements that you can make. And the eDNS client subnet standard, that's actually how that project came about. I happened to see the standard announced, realized that maybe I could measure this thing that I'd actually wanted to understand for a while. It had been impossible to measure at a global scale before. And so that ended up leading to some work that we did. Drafts and standards also are potentially a way of learning about new problems to tackle that are operationally relevant. So the ROA example that I gave is like that. There's a new standard. We want to understand how it's being adopted. We want to understand maybe which efforts to encourage adoption are useful. And so in this case, that project came about because we'd written a paper about our peering testbed. I gave a Nanog Lightning talk about it, and someone approached me who was working on routing security afterwards and asked if we wanted to work together on this. So we're just starting out the project, but that's the imaginary future paper that we're going to write. So looking at these 3 different roles that IETF drafts and RFCs played, I realized that actually they happen to align perfectly with the 3 measurement challenges that I started with. I think I'm not going to say very much about this just because I'm too new here, but I think that there are really useful things from the IETF community and also from operational communities that have been really helpful for us as internet measurement researchers. Anything to encourage communication. So people host interns, there's scholarships to IETF meetings, Nanog meetings. I think the ANRP prize is a great idea. It tends to award a different sort of work than SIGCOMM might award. And I think also this idea of bringing together different communities is fantastic. So it's been happening in SDN with SOSR, ONS, and SDI. I think RAIM is a fantastic example of this. So there's so much interesting measurement work going on, but it can be hard for it to actually have an impact on the internet, and it can be hard to understand what questions we should be going after. My view is that we should be trying to encourage the impact of these projects by maintaining them over long time periods. And so I'd just be interested in hearing ideas from others on what we could be doing along these lines to encourage measurement studies contributing back to the community. Thanks.
We have time for questions?
Yes.
Great talk, and welcome to the IETF. I hope you stick around. Can you put your slide back on the sort of the cycles of influence? The one,
Yes.
the whole consolidated one.
Do you want?
Yeah, that one's fine. So, I think that you can add another arrow with your IETF draft standard box, which is oftentimes we develop technology in the IETF based on our idea of how the internet works. And I think, you know, everybody who's involved in measurement knows that we don't really have a great understanding of how the internet works. And so I think that the outcome of measurement can cause changes in standards and drafts. And I think ANRP is one way that works, but there are lots of other, you don't have to go through ANRP to publish a draft, and then that can cause an ITF activity happen to say, oh, oops, we can do this better. So it's another variation of influence operations that influencing standardization, but that's like beyond operations, and now you're influencing industry and all sorts of stuff.
I completely agree. Yeah, and I think the collaborators on the TCP project made some initial steps to that, although it didn't end up following up with versions of the draft. So actually, one thing that I'd be kind of curious about. So attending IETF seems like a good way for understanding, what sorts of measurements could help inform these drafts. What are good ways of actually pulling that out? That it's like a week-long thing. There's all these different groups. Some people don't necessarily have the opportunity to attend in person. What would your advice be for people who want to figure out, where should I be looking for what measurements would be useful?
All right, so Aaron has informed me that I have to think out loud at the microphone because he'd rather think quietly behind me. So I actually came up here to say to answer a slightly different question that you didn't ask. You know what? I'm thinking aloud too. Are you ready yet?
Yeah.
It's late.
So this is hard, right? There is not a great track record of researchers coming to the IETF and being able to pull out useful questions. And it's something that when I was IRTF chair, I wanted to see happen more, and I think Lars has been working on that, and we've made some progress on it. But people don't come in here saying, I have a research problem. They often say, they come in with a solution, and the solution may be fixing a symptom, and the symptom may be for something that's actually rather deep and profound. And measurement is a part of understanding the root cause. And so I learn a lot from discussions about chartering new work, because often, so the activities in the ITF where people have to really explain themselves are usually BOFs, which is when we talk about new work. And every once in a while, you'll hear a knockdown, drag-out argument where you get these huge lines at the microphone, and there's a lot of yelling and screaming. And that's actually a great learning opportunity, because for the group to try to get a common understanding of what they're talking about, people have to sort of expand on the rather condensed versions of what we talk in, like, the secret language of the the internet networking community. And so so I think that's one way to do it. There are researchers here, and I think that connecting with them is a good way to sort of find out what's where some of the more fruitful areas are, and the research groups. Lars may have some ideas too.
I mean, the ITF has in recent years become much better at this, right? So there's a mentoring program, for example, and if you want, right, you can say, hi, I'm new and I'm interested in having somebody show me around, and if you're a university professor or somebody, they will try to match you up with a researcher, and they will ask you, what are you interested in, and then they will try to find somebody who has the same interests. And that seems to work okay. It's mostly working for young standards engineers at the moment, because that's where most of the applications come from, but it should work for researchers as well.
I heard something that you said, you kind of went really quickly over when you're talking about, okay, well, how do I figure out how to start? The mentoring program is a good start, but there you're pretty much investing a week. And I found when I started participating in the IETF, it took me, even though I had a relatively focused thing that I wanted to come work on, it was like my third meeting by the time I actually, so that was about 3 weeks of time that I'd put in order to sort of be able to, that's a lot to ask somebody who's an assistant professor or grad student for.
For me, I've attended NANOG and RAIM meetings for quite a while. And
so that's an easier sell, right?
Yeah, but it does take a while to figure out.
It takes a while to figure out what I mean, like, you have to actually believe that you're there for a thing in order to put up with the sort of the not the learning curve, but the entry curve. let me sell you something that doesn't exist yet, but that I hope that we can make exist.
Great.
So Lars is on us to change the name of our proposed working group or proposed research group. OPS, how ossified is the protocol stack? Question mark, which actually breaks the tooling, I think, putting a question mark in a working group name. Just semicolon drop tables in there.
No, we can do Unicode notes also.
Yeah. Oh, okay, cool. So, there's probably a scope to expand this to be a sort of an applied measurement. We don't know what the scope is. Please come Monday morning and help us have that discussion at the end of the working group meeting as a way to match up. We started with this path impairment, middle box thing. I think we want to expand the scope there, the technical scope there. We want to keep the focus on matching up people who have techniques with people who have data, with people who have problems. And we really want to bring the people who have problems, right? That's sort of that's the missing part of that. Yep. And I think that could, if we're successful in building that research group out, and we meet like every IETF, that could be the landing pad.
Let me plug here that research groups don't need to, and maybe this one shouldn't meet at every IETF, but maybe meet at every IMC as well, or something like that, right? And IMRG did this for a while. And
we've thought a lot about how we can then also sort of take this research group and put it out into the community, so it's not just come to us and play by our rules, and then we will be nice to you. But it could be a very nice place, a very sort of soft landing for researchers. And especially if we say that this is one of the goals of having this research group, and having, for the meetings that are at the IETF, having them sort of be an introduction for the research community, I think that we can do good there.
Sounds great. I'll be there Monday.
One other quick thing what I want to mention is, as a measurement researcher, your reception at the IETF is probably much better than if you come with a solution, but because you're actually providing insight rather than wanting to sell something. The negative initial reactions usually come when people come and want to, get a standard for something. If you show up with data or insight, you're usually getting a very, very nice treatment.
Yeah, I think I'd like to follow up on that. Leslie Daigle, I'd like to follow up on that and sort of amplify my earlier remark. I don't think we know, for some value of we, that's this room or maybe the IETF, how to think about this well enough in the internet context. So I think that you might go to working groups and try to ask questions of people who won't really understand what you're getting at, right? So I would actually suggest that write some internet drafts, put it out there, be dumbass stubborn, and keep putting it out there. And the people who figure out that you've got answers to their questions will find you, and connections will be made. I mean, that in addition to what Brian was suggesting.
Thanks.
Okay, thank you for your presentation. It was really interesting. I do appreciate the fact that you reminded us that it was quite difficult to make measurements, especially because sometimes data sets are incomplete and not representative of the reality. And I have a question for you and for all of you folks, in fact. Do you think that in a way, because you measure the internet, you are going to change, to have an impact on the internet? I mean, does the measurements change its structure and the ecosystem? And why? One reason for me to ask this question is that today measurements have become very popular over the past few years. Regulators in many countries, they ask ISPs to make measurements so that they can be ranked in terms of quality of services or experiences. Content providers, they do their own measurements, and they propose ranks of ISPs and so forth. So in a way today, for the ecosystem in particular, measurements can have an impact on for instance, on ISPs, their ranks, the way their strengths in the internet in terms of actors. So do you think that measurements are going to change the internet and its structure, especially because, and if so, do you think you have a responsibility as searchers, because you provide measurements, and those measurements, they can be just wrong, because whenever you collect a lot of data, whenever you apply some algorithm on it, you're going to have a result, but you can't be sure the result is good or not.
Yeah, so I agree that it does seem like there's kind of more effort to expose information about performance and things like this as a way of ranking and quantifying ISPs and then is having some impact on them. I think you raised a really good point that the methodology behind that needs to be careful. It's similar to what Randy was saying earlier, that any measurement technique is going to have limitations to it, and there is a need to be kind of upfront about that. Emil and someone else earlier also brought up a relevant point, which is that you have to be careful when you're doing these sort of characterizations that people don't tune to the measurement report, but not to anything that actually matters. But kind of having transparency along that seems like.
Okay, thank you.
Okay, we're going to take a very curmudgeonly break. I would like to refer you to the October 2005 CCR, a very short bit, into the future with the Internet Vendor Task Force, a very curmudgeonly view. The fact is that 90-something% of what goes on in the ITF is vendors looking for features to standardize, to shove down operators. It is not users trying to get vendors to standardize to make their lives easier. Okay? Just take note that the IRTF is separate from the IETF. If it was easy, you'd be in the same room. It's not. It just isn't. As far as sharing data goes, when the guppies in the fish tank notice that there are sharks, they don't share food very easily.
Hi. I'm feeling insufficiently curmudgeonly.
I was just looking at Colin's face, trying to follow up on that.
I mean, I'm curmudgeonly, but I'm not that curmudgeonly.
Why? I mean, you've done SIP, and
yeah,
you should be at least as commercial as Randy by now.
So yeah, I mean, I've been coming to IETF for long enough that some of this should maybe have rubbed off. I don't know. I mean, IETF is hard for newcomers. I think Brian underestimates the time and expense to become involved. It's not 3 weeks of your time. It's 3 weeks, 10,000 emails, and a few $1,000s to get here. Right, and all of that matters. I think it's valuable to get academics here. I think that you can get a lot of value from coming to the IETF once you've figured out how it works. And we need to align the incentives to get people here. And I think this is one of the things that the IETF could perhaps do better, because the IETF is great at organizing research group meetings. It's great at organizing this sort of event, but these are not the sort of things where coming here is something I can put on a CV, or as a student can put on a CV. We don't review the papers. We don't. All of those processes that go along with an academic conference. And perhaps we could, for at least some events, and maybe give more incentives to bring people here and actually publish the papers and do a proper review process and so on, and do it in conjunction with SIGCOMM or something.
It's possible for some research groups to operate that way, because research groups can basically make their own rules. And I think some have like a program committee, but it's not advertised as such and it's not as visible. For the ANRP, actually, when Matt and me talked about this a long time ago in Prague, right? We did actually want to create something that people would put on their CV, and I've seen it now on, I think Toby has it on his, right? Because it's an award that you get, and so you list it.
And the ANRP is great for established people who have a paper and they can submit it and then they get the recognition later. It's terrible for a student coming in, because they can't submit a paper to it and get it. Hey, it's a review publication. I can get some funding.
Most of the winners are students, because we always usually pick the first author of the paper, which is usually the student. So I think we have actually more student win than non-students. But it's a small thing, and we can't give out so many of them. So we need to find something else. I think that's what your point.
We can align the incentives in a way that people can spend their own money to get here. If we give them something which helps them.
Okay.
adopts their CV.
I
I'm
gotcha.
not sure we do that very well.
Yeah, I think in terms of spending money to get here, funding from within the university tends to be like, if you are giving a talk, then you
Yes.
can be funded. And
Exactly.
so even having students give lightning talks ends up probably making a difference on some of that.
A lot of
and
it
then
is
travel grants from
if,
here.
if you're
obviously help.
giving a peer-reviewed talk where you can say, look, this counts for my CV. This has been reviewed. It's something that's worthwhile. You know, it has impact. Then I can get funding for it.
Keep
Otherwise it gets hard.
that topic in mind for the IRSG dinner to which you're now going. I hope. Because so we do
Getting
need
free food, right?
So one of my sort of things that I've tried to change a little bit about the IRTF is not having it operate so much like the IETF, because we don't have to. We have almost no rules. It's just convenience to, you know, because we're meeting in the same place and there's a lot of people over there, but we don't have to be like them.
Yong Cui from Tsinghua University. So I think the combination of measurement and the IETF or RTF is quite important. But from my opinion, I think there are some difficulties for the real combination, you know, because we maybe, generally speaking, we find some technical problems based on our measurement. But the problem is when we try to deliver this problem to IETF or RTF, you know, we have chartered research group or chartered working group. So if the problem can fit into a special charter, that will be okay. Otherwise, it will be difficult to deliver this problem to IETF, you know. If the problem is quite big enough, then we can have a both or maybe new working groups. Otherwise, it will be difficult. So that is one issue. Another one is once we find the problem, maybe we also need to find if the problem can be solved or not. If it can be solved, then we can go to IETF or make a new solution. Otherwise, it will be difficult. And maybe the third issue here is, generally speaking, when we read some papers may focus on some special algorithms. You know, algorithm that is not a protocol. So, but IETF will focus on the protocol side. So that is difference. Okay.
Right. Yeah. So not all research is you know, useful to bring to the IETF. Fully agree with you. I want to push back on one thing which you said. So in the IETF, I also agree with you that it's sometimes difficult to bring new work if it doesn't fall into a charter, because IETF working groups have very tightly controlled charters. In the IRTF, we try to actually be pretty broad. Yeah, there are some areas where we don't have a research group at the moment. Like there's other than crypto, for example, there's no security research group. There isn't anything that's very operational. And excuse but the network management research group doesn't seem to be terribly operationally oriented. But that shouldn't stop you from trying to start a research group, or if the topic can be made to fit into one that exists. It's easier to bring it to the IRTF, I guess what I'm saying.
It's a random idea to have something parallel to the Applied Network Research Prize, to have a from IRTF to IETF prize. So
what would be?
so your prize would be, maybe you get some money to come to a few meetings, and you get some mentors to guide you.
So I'm giving a prize to the IETF?
So no,
I'm using my little budget to. Sorry. No. So who's giving the prize to whom?
Whoever gives ISOC, whoever gives the prize now to the ANRP, they give another prize, which is to people who've got research work and they want to try and get it standardized in the IETF.
Okay.
So you know, there's a review panel. Here's some ideas. Here's the review panel. And we pick one or two of them. And the winners get, because they're considered promising, the winners get some money to come to some meetings.
Cut after Karen cut the topic, because we're going a little bit off the topic of the workshop, but I wanted to let it run now. But yeah, I love to spend ISOC's money too.
This is the wrong time to be at the mic then. Actually, I wanted to speak just briefly to the IETF people in the room, because I think that I think it would behoove us to spend a little bit more time thinking about the work that we're doing and identifying where research would help, and highlighting that in some way. I'm not exactly sure what the success of this will be, but the TLS working group has been working on the 1.3 specification. They're planning to not freeze it, but they're planning to hold it up for a little while and hold a workshop specifically to bring researchers in to look at the TLS specification. So I think that, and perhaps, Randy might say I'm being overly optimistic, but I think that's a model where I think the IETF has looked and said, we really need to bring in research to talk about this. And I think that, I don't know how you could make that in a process way so that it's easier to find, because I'm very sympathetic with the person who made the statement that, you can't just say, come to the IETF. The IETF is, thousands and thousands of emails. How do I find where I can have an impact? And I think we need to help identify those the places where there might be opportunities.
Yeah,
We had this idea almost of like Millennium Prize style list would be like extremely useful if there was kind of compiled, these are questions that need answering. One
thing that led to the ANRP was actually when I was Transport Area Director, Magnus and me started to invite people that we had seen at research conferences to talk at the open area meeting of the transport area. Like, who's it? I'm blanking on the name. The SST transport guy. Yeah, Brian Ford, when he's still doing transport. So he was, for example, he had a paper on this. We thought this was cool. The transport area should hear it, and we invited him. And I think Russ or Brian at the time as IETF chair used the discretionary budget to fund the travel. So the IETF can do this. They're not doing it very often, but that worked really well, and we quickly realized those were actually the best talks during the entire week. Were these guys, and that's what the ANIP tries to sort of codify, so that the IETF could do this.
Right, and I think that like the working group chairs and the IETF leadership could spend not they have a lot of time, but just think about that.
Area director approaching the microphone.
So I'm Spencer Dawkins, one of the two transport area directors, which means that we chair the TSV open area meeting. We're actually really excited to have talks, talks like this, like the ones we're talking about here now. So I know that not everybody is working on stuff in transport, but if people are working on stuff in transport, we're, like I say, we're excited to make that available to people who present research as well.
Yeah, I'm sure Toby would love to come back and give another talk.
I'm sorry?
I'm sure it's my student Toby, who came and gave a TCP talk for his ANRP, I'm sure would love to come back and give another transport talk sometime.
Cool. Thank you.
You got the last question.
Okay, so RAIM this year has clearly been very nice. So what stops us from having it every year?
Co-location of the communities makes it easy this year.
Right. I thought at least yesterday at the end of IMC, it seemed like the local chairs just spoke to just thought, oh, okay, what else is going on in Tokyo? Let's put people together. Why isn't it possible to plan ahead?
It's not impossible. From the IETF side, we have the problem. Our meetings are fixed until like 2075 or something like that. It's insanely far into the future. So it needs to be the IMC side in this case. But otherwise, and individual research groups can and should meet with conferences. So we have this Gaia, Global Access to the Internet for All research group that meets regularly at ACM Dev. They hardly ever meet at the IETF, but that's cool with me. And that group works really well. So there's no need for research groups to actually, as far as I'm concerned, ever meet at the IETF. It would be nice, but if I have the impression that otherwise the group functions fine, they don't need to be here.
IMC 2016 is at USC where I am, so everyone should come. I can't offer any travel grants myself, but come hang out.
Unfortunately, IETF's in Korea the week after.
It's on the way from Europe if you're going. Yeah. Do we want to take 2 minutes to get refreshments before we start into the lightning talks? So don't leave the room, don't start conversations, just go quietly, get drinks and sit back down. That was really good, thank you. I'm shocked that nobody spoke about Ethan pulling out the podium. Oh. Oh. All right, let me. Yeah, otherwise I got confused. Hang on. Which ones are wrong? Steven Strauss is also right. That's right. It needs to be Strauss. And who else is wrong? Enoch Erdley is not. That's right.